close this. Open up our dungeons and data structures. Okay, so we want to, let's go back to our, I guess we're already there in our main activity. Let me hide some of these things so we can see more of the code. All right, so down here where we have build dungeon, we're going in and we're building out all of these rooms, right? Now, what might be nice is for us to have all of our rooms and the exits that link those rooms stored in the database, and then for us to pull that in here. Make sense? So that if we wanted to add new rooms, I'm kind of thinking maybe we want to have maybe our app go into like a builder mode, where when we're in a builder mode, you know, kind of an edit mode, I guess, we can say we want to create an exit to the north, and that'll create an exit there. So it'll actually create a new room up there for us. So we could add new things from within the thing. It'll store it in the database, and then next time we launch the app, it'll bring that back as if we had created it. So kind of giving us a real example of kind of a purpose for storing things in the database. Make sense? So we want to start off pretending like we've already done that and being able to restore our dungeon from our database rather than having to rebuild it each time. All right, so as I see it here, we're definitely going to need, well, we want our game to support multiple dungeons, right? Okay, so we're probably going to have a unique identifier for a dungeon in our database. So if let's just open up Keynote here and kind of think about how we might describe this. All right. So we're going to call this database design. All right, so we're going to have probably a dungeons folder on there. And then I'm thinking we would have, for each dungeon, you would have like a unique folder for it with that push thing that we looked at last time. So maybe like the ABC 1, 2, 3 folder that is generated from push. So that's going to be our unique identifier for a particular dungeon. This dungeon would have a name. And then this dungeon would have a collection of rooms. And this dungeon would have a collection of exits. So for us, name here would be, let's just do CS department. Under rooms, we're going to have S120. Actually, we would probably have R001. I kind of want to have this like random number, so I'll just bang on the keyboard. So we're have a unique identifier for each of our rooms. I'm thinking exits is separate from rooms because exit is a marrying of two rooms, rather than there being an exit.
Because like in real life.
Right, we're going to build it from this. We're thinking about how we're going to store it. So we're storing the information about our dungeon up in the database. So I need to have my collection of rooms, and then after I have my collection of rooms, then I'm going to have my collection of exits, which marry those rooms together. So I kind of need to process my rooms, bring all the rooms in first before I can have those exits created. So maybe storing them separately. If you wanted to put it inside of rooms, it's not going to be the end of the world. But we really need exits to be a collection, not inside an individual room. Okay, so rooms, we'll have, actually, let's just call this, I'm just going to throw UI, well, no, that didn't help either. UID. So whenever we say UID, we need to do that push to get the random number, the random folder num. So for a room, we'll have each of these rooms will have a unique identifier. Then we'll have the room name. So for instance, we might have S120. We'll have the room description. I think that's it for. Yeah, well, yeah, just whatever we want to call it. All right, so I think that's it for what we need to have in rooms. And then similarly, we would have a second room. At least not right now. We might go back in and update it, but like right now, we have one player. We just insert them into the world. So we're going to kind of start our database off with something. So second room we have is what is it? CS hallway. Description is equal to just whatever, CS hallway. All right, so those are our rooms. Now, and I think this is where you were talking about where exits need to go, because technically we have an exit where each exit's going to have a unique identifier. It's going to have a room 1. So maybe this is S120, and it's going to have a room 2, and that's CS hallway. So in our world right now, we only have one exit, the exit that links these two rooms together. So now up in rooms, though, we need to be able to, how do we then get these rooms linked up here, get these exits linked into the room so that we can build them at runtime? So inside of a room, we probably do need to have an exits folder. And inside that exits folder, we would have, so from S120's perspective, we would have north. And its value would be this UID for this exit. So it'd be like a string that knows about that exit. Should I make it smaller? Do what now? Yeah, here, it's going to keep getting smaller, so let me do something here. Yeah, so for our exits here, if I'm thinking about from S120's perspective, we have a room to the north. We have an exit to the north. And which exit is that? The exit whose unique identifier is this guy down here. That's how we're going to have to link those together. And then similarly, for this room, we have exits. This one's to the south, equal exit UID, whatever this unique identifier is down here. All right, so I guess with that in mind, if we're going to completely build our dungeons in the database or using a tool outside of this, rather than having unique identifiers, we could actually have our exits numbered 1, 2, 3, 4, 5, 6, like that. That wouldn't hurt anything. So we could store our exits that way and then number those exits up here. So this would be, you know, the north would be exit 0, and this is also south is exit 0. Because that's linked to this maybe ArrayList of exits down here, which is my first exit is exit 0, and that's the exit that these guys have to their north and to their south, respectively. So rather than letting push come up with some random thing, we'll just make sure we have unique identifiers for all of our exits. Exit 0, exit 1, exit 2. That way we don't have 2 exit 5s. Make sense? All right. Although we can use push for the rooms because I think actually it doesn't necessarily make a difference. Rooms could be the exact same thing as well. Just as long as each room is unique. It's room 0, 1, 2, 3, so on and so forth. Now for a dungeon, we do need to know start room. And maybe we decide that's rooms, in this case it might be room 1. Because this room is, let's say it's room 0, this is room 1. So inside rooms, I have two rooms, a room 0 and a room 1. So we could probably store and retrieve array lists of rooms here, actually. That'll make it pretty easy, actually, to work with Firebase for this. So we'll do that. We do need to mark the ID of the start room. So start room is going to be the room at bucket 1, which is actually our CS hallway. I think that's what we had set in our thing. All right. So I think that's a reasonable starting point. So let's go ahead and let's have our, we're going to have our program build the database if it isn't already built. All right, so rather than actually going in and putting it in by hand to begin with. So inside of Firebase here, here's our database. I'll go ahead and hit getting started. I'll make sure this guy's in test mode. All right, so this is going to be our database for dungeons and data structures. All right, now we're definitely going to have a top level thing here. So I'm just going to hit a plus sign on this. And we're going to call this guy dungeons. Oh, did I lie? I have no value for that. I want it to be a folder. Can I not add it in here this way? Yeah, you might have to do that programmatically. That's okay. We'll do it programmatically. All right. So in our build our dungeon thing, did we do? We didn't bring any Firebase stuff into ours yet, did we? Okay. And did we connect this up? Dependency setup correct. I need to change my account here to be this one because I created this one under that other account. I think I saw this in another class. This is actually a bug. Once we've already connected it, it's fine. This guy is connected. We've already added the dependencies for it. So go ahead and close this guy. I'm going to open up that other project so we have some of the Firebase starter stuff for us to grab. All right, so we already have our room and our exit class. So to make these, so we want to kind of think about these guys in terms of how we're going to store them. So come back in here. Here's room. Now right now I have rooms have a linked list of players. They have a linked list of NPCs. We're not going to worry about storing those guys yet. We do have this hash table of string and exits. So that's going to be, I think that's actually is something that we can store. I think you can store maps in there. So what I'm going to do is I'm going to make all of these guys public to prep it for Firebase. All right, and we'll go ahead and let it go ahead and create the players and the NPCs and those guys. All right, we then need a no argument constructor for room that, let's say, does nothing. Okay, in fact, let's just save ourselves some space here. We'll just put it like that. All right. We technically don't need all these getters and setters now since we made them all public, but we're going to leave them since we're using them for other things. I think it's a nicer way of working with it anyways. let's say that guy looks okay. Let's do the same thing with a player. So a player is actually a type of character. And we're going to go ahead and make these guys public. Again, to make it compatible with Firebase, we're going to give ourselves a public character constructor that takes no parameters. And the rest of that should be okay. Then we'll go in and modify player and NPC. So we have no fields in here, but we still need to have a public constructor. Similarly for NPC, we'll have a public no argument constructor. And then for exit, we'll make our 2 rooms public. And then give ourselves the no argument constructor. Remind me, why do we need that no argument constructor? How's that guy used by Firebase? Not for push.
No, for retrieving.
Okay, so when we retrieve something from the database, what actually happens?
It will call the constructor.
Which constructor? Which of these two?
The empty.
Okay, so it'll call this guy, and what will that create? If I create an exit saying exit E equals new exit, passing it no parameters, what will I have after that? I'll have an exit that has no data in it, but it's physically an instance of exit, right? So that's what Firebase does first. What does Firebase then do?
It will use the public
Yeah, it'll set the public fields. So rather than, as a human being, we would go ahead and create an exit E equals new exit, passing it room 1, passing it room 2, letting it create the exit that way. Firebase will go ahead and create a blank exit and then say E.R1 is equal to whatever the first room is. E.R2 is equal to whatever the second room is. Make sense? All right, so it'll build them that way. Okay, so I think we are good there with exit. I'm sure Firebase and Android will be happy to scream at us if we screwed up. NPC looks good, player looks good, room looks good. Dungeon, we need to do the same thing here. So we need to have a public dungeon, no parameters. Then we need to make its fields public. Okay, good enough. All right, so then in main activity, let's just start off by seeing what would happen if we just try to store a dungeon. Because that's effectively what we're building here. Inside of main activity on build dungeon, we're creating 2 rooms. Then we're creating a dungeon, creating an exit. We're adding that exit to our 2 rooms. Those 2 rooms are already in the dungeon. Well, the dungeon is kind of a linked list, right? So we're adding the start room to our dungeon. So here's our dungeon. It keeps track of the start room, but then it also has a collection of all the rooms that live in the dungeon. Yeah, actually, it doesn't look like I'm ever actually adding those other rooms to the dungeon. It's really what I should do is I should say this.cs department.add room S120, this.cs department.add room CS hallway. I'm not even sure that's even I mean, we're certainly not using it now because it worked before. So inside of dungeons, we're holding on to this linked list of rooms to keep track of all the rooms that belong to this dungeon. But the reality is if we think of dungeon as kind of like being a linked list data structure, and the head of that list is the start room. Using the start room, can't we get to every other room? Yeah. If it doesn't have an exit, then the room is useless, right? Is the presumption. So I don't know what to think about this. I think there's still benefit in keeping all the rooms as a child of the dungeon, but then making sure we know where this dungeon starts. But right now, we're not actually using that room collection. And when exits are created, those exits hold the two rooms that they link. So they're not reliant on a collection either.
You need just to tell how many rooms you have in a dungeon.
I don't even know if we need to know that. So to simplify this, I'm going to go ahead and I'm going to remove room collection. We'll always put it back if we decide we need it. But if we're treating dungeon as effectively a linked data structure, where we just need to know about the very first room, and that guy links to however many other, it's an n-ary linked list, right? It's not necessarily just linear, because it's kind of like almost like an n-ary tree, where our start room might have exits that lead to 0 or more rooms. In our world right now, up to 4 different exits can link off of our start room. And that's all we need to go to that next room. And then from each one of those, they link to potentially up to 4 other places, so on and so forth. So really our collection of rooms is kind of internally housed inside of our linked data structure. So I'm going to go ahead and remove all occurrences of that. So adding a room to this dungeon doesn't really make sense here. We do need to add a start room. Okay. Go back to main activity. So we'll get rid of these 2 add rooms. We weren't using them before anyways. All right, so we'll define a couple of rooms. Then we'll define the CS department and tell it what the start room is. Then we're going to define 1 exit, and we're going to add that exit to our 2 individual rooms. Okay, so that's really all a dungeon is at this point, right? So what we'd like to do now is we'd like to store that dungeon inside of our database and see what it looks like. So what I'm going to do is I'm going to grab a couple of our stuff from over here. So we'll go to main activity. I'm going to need several of these guys. I'm going to steal all those right now, all of our database stuff. Okay. Then let's just deal with the writing of stuff. So I'll grab my couple of database references here. Grab this top one. We'll go ahead and put this inside a build dungeon for right now. So we'll go ahead and get our reference to our database. And then we're going to say we're going to store this inside something called dungeons. Okay. And forget about the listeners for right now, because the listeners are for reading stuff back in. We're just looking at writing our dungeon to the database and seeing what it looks like. So we're going to go down here, and we're going to, I'm just going to steal this code right now. We'll modify it and talk about it. Okay. So each of our dungeons needs to have a unique name, right? So we have a folder called Dungeons, and then we're going to have we could say Dungeon 0, Dungeon 1, Dungeon 2, but it probably makes sense for us to say that a dungeon has this unique key associated with it. So off of our, we're going to call this guy our dungeon reference. So off of our dungeon reference, we'll do a push, which will give us that unique folder name. And we'll go ahead and we'll store that inside of, we'll call this guy temp dungeon. Okay, now we already have a dungeon object that we want to store. It's called the CS department that we created. So we're going to, So we're going to say temp dungeon set value to this .cs department. So we're building the exact same objects we built before. We simplified them just a little bit. And now we're going to go ahead and we're going to tell Firebase to, well, we'll get a reference to the Dungeons folder in Firebase, which currently isn't created, so it'll create that for us. Then we'll get a unique folder in there, and then we'll go ahead and push. Well, the unique folder is the push. Then we'll go ahead and set the value in that unique folder equal to whatever Firebase decides to do with our objects that we've created that relate to our dungeon CS department. All right, so any questions about what I'm doing here? If it makes you feel better, we can put all the Firebase code right next to each other. So this actually writes it to the database. All right, so let's run this guy. Oh, by the way, while this is launching, did anybody leave this at the hackathon? It's a pretty good, huh? I don't know. Yeah, I don't know that it started in this room. Dr. Locklear just gave it to me and said ask around if somebody left it, since nobody recognizes this as being theirs. Do not have rooms yet? That's okay. Let's see, what's he not happy about? Just for a moment here, let's just take out the set value and make sure that's where it's dying. It's got to be one of our objects probably. Yeah. Okay, so then as soon as we actually try to store it, could be one of those linked lists needs to be an array list or something like that. For right now, because we have some complexities inside of Dungeon, inside of Room rather, we are going to need to know about the player. We are going to need to know about NPCs. I have a feeling about these exits. This might be the issue. Let me dump that for right now too. Let me just comment these out.
You can select multiple lines and
Control backslash.
and same thing to uncomment.
I'm guessing it's a command. Front slash? Oh, it's front slash, not backslash.
I never.
No, whatever. That worked. All right, and then we get description name. Those guys should be okay. This guy should be okay. Actually, we don't even need display anymore, really, because now we're showing it on an actual screen. That's add exit. That's take exit. We probably want to comment out take exit for right now. I'll comment out these couple of lines. Same thing down here for our NPCs. We're just focusing on getting the most simple form of our dungeon stored in Firebase first. Okay, so some of these functions aren't going to work right now, so we shouldn't hit the buttons that make them work, but we're hoping to get them to at least store. All right. This guy's still upset about something.
This is that dot save data. Set value.
What are you talking about?
Is it dot set value? Is that what it crashes?
Yeah, because that's where we're actually writing it to Firebase. I mean, that's the one line that actually does all the writing. So the issue it's having is probably with some of our objects. I'm guessing the hash map.
Reference, like somebody else will have the same error. Says something to do with forgetting to add the reference.
No, it's our objects. Yeah, if you look at our dungeon, not our dungeon, our room, we have some fairly complex things going on in here that we're trying to store. It's got to be one of those three. I'm guessing it's this hash table that it doesn't know how to store. So I'm going to remove those guys out. We know it can store a couple of strings, right? We know it can store rooms because we've taught it how to store rooms. And then we'll go back and look at what do we need to do to loosen these guys up or rewrite them a little bit to, I think it knows how to do array lists, definitely. So we can update our linked list to be array lists, that kind of stuff. So let's just get it storing in the most simple fashion first. All right. So I'm basically breaking our entire program. That's good because then we get to go back and fix it. These are just stupid little for loops and stuff. All right, this is hiding buttons. So I'm just gonna get rid of all those for right now. Okay. So it wrote. So here is our room that doesn't have any functionality because we took everything, commented everything out. But we do have a Dungeons folder now. Inside the Dungeons folder, we have the result of a push for this unique dungeon. Inside of that, we have the name of this thing is the CS department. Inside of that, we have a start room. Okay, so we didn't get any of those other rooms. So we have to, just because a room connects to that doesn't mean, all right, let's go back and look at this. So this is our dungeon. A dungeon has a start room and a dungeon has a name. Now when we stored that start room looked like this. This is our start room. It has a description, it has a name. So if I go to room, oh, that's all they're supposed to have right now, a description and a name. So far, mission accomplished, right? My room has 2 public strings. It stored both of those public strings. Now, it would probably be helpful if I could have in there that collection of exits. All right. Oh, I'm sure we can. We just need to make sure we're using the right kind of animals. Because when they wrote Firebase, they had to say, these are the types of Java objects that we're going to allow you to write to Firebase. Because they had to write the mapping for that on their side. Something in the realm of a hash table probably will work since hash maps were part of this. So let's just do just this part. And we will try to store this hash table. So this hash table was added when we tried to put an exit, right? We added an exit to this guy. We're not going to take exits yet. We're just going to try to build the data. We're not going to worry about players right now. Okay, so now this should give us the ability to get stuff into that hash table of exits. So back out here in main activity, when we're building our dungeon, here's where we're adding some exits to those rooms. So that's filling some stuff up in the hash tables. So let's take a look at that. All right, so what I'm going to do then is I'm going to go in, I'm going to dump my database for right now. So it's as if I didn't write it that previous time, and let's now run it again and see if it writes it better for us this time. Okay, so that guy did crash, but it's possible that we're still okay. Somebody crashed for a different reason. Nope, it did not write. So let's look at logcat here. Yeah, it did not. Oh, hold on. I think we're still okay. What I'm going to do here is I'm going to set my hash table up as a new. Yeah, but we're not calling that constructor. Oh, we would be. You're right. We would be, but they wouldn't necessarily be. But I think you're still right. Since we are calling this constructor, we could have put it up there as well, but this makes more sense. Because when we use this to read it back in, they're going to be setting the data to it rather than constructing it. So this should be okay. Yeah, so our problem was this guy didn't even have a value. And we were trying to add exits to a null value. So we were crashing before we tried to write. So let's run that again. Okay, died there, so I'm predicting it did not write to the database. It did not. Okay, so it's probably not happy with a hash table, but we should be able to use a hash map. I'm not sure why those are so different. Okay, so let me just come up here, and instead of hash table, I'm going to say hash map. Same thing there. I'll just change the animal a little bit. Still didn't like something there. Wonder if it doesn't like the hash aspect of that. Let's just do a map. Oh, map is abstract. Can't do that. Let's keep it generically as a map, but call it hash map there. That didn't work. Let's keep it empty, but still in existence. And see if it's crashing from our stuff or from the right. All right, so that launched. That wrote. There's our start room. Oh, but because it's empty, it doesn't write anything in here. That's unfortunate. Okay. So when we say a room, add exit. I'm going to switch this back to hash table. Oh, hash map rather. No, it's hash table like that. So this dot exits dot push or dot put. That guy should be pretty happy. I really thought it could store maps. Let's look. Firebase, Android. Yeah, we're effectively already doing that. I mean, this is what our exits, our name exit pairs as a hash map. Oh, it says set value async. Well, that's the only, yeah, well, yeah, async is doing it without blocking, so it just happens in the background. That is the one thing that's different from ours. Because for us, we're putting a, north with some exit, south with some exit, and then we're setting the value. We're not setting it asynchronously, but we're setting the value. And it's definitely doing it as a hash map, which is what we did have. Make sure that's all public. That's set up to be something that's storable. Those are all public. Well, so let's just try the async, saving it. Set value async. Oh, it doesn't look like async exists anymore. Now they just have one with a completion handler. So here's us adding some exits to the CS hallway. So this is the guy we should actually be writing. And it's going to store key south, and the value is going to be S120 CS hallway, which is an exit object. And an exit object has two public rooms. Rooms have all the public stuff, but it also has a map thing in it. I wonder if it's having like an internal, almost like an infinite loop. Because when it tries to write that room, so when it writes this exit, it has to write the room for that exit. Well, two rooms. When it goes to write this room, it's going to come into room, and it's going to have to go through the exits that are associated with this room. So I see it kind of bouncing back and forth, like getting stuck in this run, because the way we wrote our exits is going to include the room we're currently in. So when it tries to write for this room, this hash map of string exit pairs, one of these exits is going to be the exact same exit that got us to writing this room in the first place, which is then going to try to write this room again, which is then going to try to write this room again. So let's see if we can have a simplified version. because we have to reimagine it now for storage in a database versus storage in specific objects like we've written in Java. Even though Firebase is built for storing objects, something that we can do locally with the local scope might not translate well to the database. And that's what I'm kind of thinking is happening here. If we walk through this and we say, okay, we're trying to store the exit, we're trying to store room 1. So these guys are public, that should be okay. So I'm going to try to store the exit associated with this thing. So that's room 1. Room 1 is then going to take me, actually we could probably, I'm just going to say public string name is equal to hello in there. And I'm going to comment out room 1 and room 2. I'll get rid of that constructor. And I'll get rid of this stuff right now too. So I'm just going to change, so an exit is only a object that holds a string. So our hash map should now be storing, like north would be related to an object that holds the name hello. Doesn't actually lead to other rooms or anything. So, because I'm suspecting that we're getting caught in a loop in the database where it's trying to write an exit, which requires it to write a room, which then requires it to write the exit again, which requires it to write a room, and it just is getting stuck in that loop. So I'm not going to, exits no longer have rooms in them for right now. Let's see if we get a successful right here where an exit has a name and that name is equal to hello. Okay, we're empty there for right now. Oh, I have to, let me just copy this line. So I no longer have a constructor that takes 2 parameters. I'm just using the empty constructor for that guy. All right, so it ran. It stored. There's our start room. There's our exits. There's our south. There's our name. All right, so the problem was the infinite loop on rooms. So we have to reimagine our exits a little bit here. So this is where it goes back to what I was mentioning earlier in our design, where an exit has a string that it links to, and that string is the ID of the room that it is going to. Does that make sense? So instead of it being the room itself, which programmatically we can hold a pointer to that room. In the database, if I'm saying this exit leads to this room, it's going to store that whole room object. And that room object might have that same exit inside of it, which is going to have to store its own room object. So that's where it was getting stuck. It was trying to write the same data over and over and over again and never able to finish. So now what we need to do is we need to map our exit. So we're going to say this guy has an exit to the north, and that exit leads to exit 0. All right, so instead of it being so tightly coupled, we're going to say, I have this collection of exits somewhere, and exit 0 is the exit I'm talking about here. But rather than putting the actual exit here, I'm just going to put the value of the exit, the position of the exit here. Otherwise, we get into that writing the same objects over and over and over again situation. Okay, so then with that in mind, I think we can fix this without too much trouble. So we'll go back to our dungeon. And at the very least for right now, our dungeon needs to have, actually I think our dungeon needs to have that collection of rooms, and it also needs to have a collection of exits. Because it's those two guys that we're mapping together for it's those two guys that we're mapping together for our where our exits lead. So because we know that Firebase supports array lists, let's create an array list here for our exits. We had a linked list before. Array list is fine. So we'll create a public array list of exit objects. We'll also have a public array list of room objects. And let's name our exits. Let's call these, let's call it exits. And we'll name our rooms rooms. Okay, those guys are public. So exits are going to be all the exits that exist in the dungeon. Rooms will be all the rooms that exist in the dungeon. And then we can do, let's start off just keeping it simple. We'll just number the things. So we have a thing to add a player. We also need to have now a way to add a exit and add a room. So we'll say public void add exit. This guy will take in an exit E. We'll say this dot exits dot add E. And public void add room R, this dot rooms dot add R. Okay, so we're kind of simplifying our definition of a dungeon. Where the dungeon is going to have a big pile of exits and a big pile of rooms, and then we're going to tell rooms, the hash map for rooms, that a room leads to not an exit, but the index of that exit in this list. So they can go and look up the kind of the portal that they have to travel through to get there. That way Firebase can conveniently store this. Let me kind of show that here. So right now we have two rooms, room 1, room 2, and then we have an exit. And this exit actually is holding pointers to both of those room objects. Now, that's fine from an object-oriented programming perspective. But from Firebase's perspective, these pointers are as good as holding the objects themselves. So if I try to write this exit, it's going to try to write this entire room object to Firebase, as well as this entire room object to Firebase. And this entire room object contains a list of exits, which includes this exit, which then is going to write this exit, as well as this guy to Firebase again and again and again and again and again. So what we're going to do instead of this is an exit no longer will link the rooms themselves. Instead, the exit is going to have this guy maybe is going to link between room 0, and that's room 1, and room 1. That'll be the second room. These guys won't have direct links. Instead, these dudes are stored inside of the rooms array list inside of dungeon at bucket 0 and at bucket 1. So this 0 corresponds to the index 0, which happens to be where this particular room lives. This 1 happens to correspond to the index 1, which happens to be where this particular room lives. But Firebase can write a 0 or write a 1 without getting sucked into an infinite loop of writing. Make sense what we're trying to do here? We're just creating one layer of mapping to keep Firebase from getting carried away with itself. Okay, so we have our couple of array lists. Let's go back out to our main activity now. We create our couple of rooms. We're cool there. No problem with rooms. We'll create our CS department, tell it where the start room is. We're cool there. All right, then we went ahead and I'm going to go ahead and create our real we'll have to do it kind of this way. So now I'm going to say, now that we've added this CS hallway, I just need to go to room rule. That's in dungeon, right? Yeah, I need to look at the constructor for dungeon and see what all he's doing when we start a start room. When I pass it a start room, he's setting the start room to that. He's not adding that room to his array list of rooms. So we either have to add it to the array list of rooms here, or we have to remember to add all rooms to our array list of rooms. It probably makes sense for us to say this dot rooms dot add start room in here. That way we know that the start room is always bucket 0. Okay? One thing we could end up doing is we could end up giving each room a unique identifier that it would link, but I think that's going to be harder for us to design rooms than just remembering this is room 0, this is room 1, this is room 2, so on and so forth. So when we first create our dungeon, it'll go ahead and load start room into our array of rooms. So then I'll need to do this dot CS department dot add room S120. Because CS hallway's already been added. S120 is now added at bucket 1. Okay? Now, for our exits, rather than having a exit go to the two rooms being S120 and CS hallway, we want to modify exit to no longer hold rooms, but to hold an int. We'll call this room 1 index. We'll call this room 2 index. So rather than storing the room itself, we're going to store the position where we could find that room. Okay. So then back here in main activity, when we create our exit, this exit is going to go between room 0 and room 1. The exits, the indexes of where those rooms live inside of our CS department's rooms array list. All right, now we can go ahead and add our physical exits to S120 and will that work? Are we right back? I need to look at rooms real quick. Yeah, so this should not be a right here where we're adding an exit to S120. So this exit already exists, right? The exit exists right there. And that hypothetically links those two things, even though we haven't written the logic to take that exit yet. When we go to S120 and we add that exit to the north, we're telling it that guy will lead to S120 hallway. which is the name of this exit. And this guy will lead to S120 hallway to the south, which is the name of this exit. I think we're going to be okay there since those exits hold not rooms, but indexes. So I think we're okay with this. Okay, and then we should be able to write that. Let's see if this gives us a little bit better, well, we'll say object-oriented wise, maybe a little worse structure for our dungeon, but a database compatible structure for our dungeon. Dungeon line 24. Oh, I never created instances of these guys. This dot rooms is equal to a new array list of room objects. This dot exits is equal to a new array list of exit objects. Okay. Now it shouldn't be writing to a null value. That guy's up there. We now have a dungeon, CS department. Here's the rooms that are in there, a room 0 and a room 1. Room 0, CS hallway. The exits are to the south, leading to, oh, I forgot to take the hello out of there for my exit, but it's leading to hello. There's very friendly exits here. So, but this exit is made up of our room index 0 and 1. Similarly, for room 1, the exits are to the north, and it is room exit 0 and 1. That makes sense? And the start room for our dungeon is CS hallway, where that guy has this exit. But because this exit isn't implemented in terms of another object, we're okay. It's going to map to those other objects because we are going to use this 0 and 1 to go and look stuff up. Does that make sense? So let's do one last run here. And we will take the little extra hello out of our exit. We no longer have this public string hello guy. Okay. Just want to make sure you had enough to do what I'm going to have you do for your homework. All right, so now it gives us, here's our dungeon, here's our 2 rooms, here's our exits to the south. It just is the 2 indexes of those guys. So this should give you a valid starting, a valid database. So I'll push this. So what you'll have to do for your homework is get this mapped to your own Firebase database, right? Because right now it's connected to mine. So you want to fork it, then you want to go to Tools, Firebase, and you might have to come up here and add an account or something like that to get it to link. But ultimately, you'll be able to click on Connect to Firebase in here for it to hook up to yours. Then, remember from last class, we already had our code working where when you hit one of those buttons, it took you through that exit. Well, we only have 2 exits, right? So if I hit north, it took me, well, if I hit south, it took me into S120. If I hit north, it took me back into the hallway and updated the interface. So I currently have it commented out, but you want to be able to go back in and be able to take an exit and have this guy look up, because no longer is it going to say, is the player's current room equal to room 1? Because room 1 is not a room anymore. Room 1 index is the position where that room can be found in the dungeons room object. Okay? So you're going to have to go and look up room 0, for example, in dungeons rooms to find out if the room the player is currently in is equal to that guy. If it is, then take the other room. That is the room that lives at index R2 index in the rooms, or in the dungeons room collection. That makes sense? So update the code to work the way it worked before as far as exits go, just for these 2 rooms. All right? Questions, comments, concerns, bribes? See everybody on Thursday.
So the hackathon that you mentioned is going to be on Saturday is for literally a client code.
Yeah, it's Kohler. So Kohler is a famous company.
Isn't that against like how hackathon works?
Huh?
Is it like that's different than what exactly hackathon is about?
No, not necessarily, because I mean they basically are saying they have a real problem they want to solve, so they're going to bring a bunch of teams together and let them work on it. And they're going to give them food and stuff like that, and they're asking for students who need experience. It is interesting that it's such a short hackathon.
Oh, it's only 1 hour. Oh, no, actually. Yeah.
It's 10 a.m. to 5 p.m. So,
I guess the work schedule.
yeah, but it's on a Saturday. Yeah, I just felt interesting that it was so short if they want to solve a real problem. So it's maybe a simple problem that they've created.
Yeah, I think on Slack. Timothy.
Trammel, yeah.
Yeah.